Thanks everyone for having your time today, and the Integrate office and the speaker who has come from Coimbatore for this workshop today. So this is a community meetup, a community called as Chennai Azure User Group. This is 122nd meetup we are organizing today, and Integrate is the venue partner. So Subhash would like to talk a few words about Integrate first. Yeah.
Hey, thank you, Dinesh. Hey, good morning, all. On behalf of Integrate, I welcome you all to our office premises and to the first external session happening in our office, external community session. Chennai is tech community session happening in our office. So as you learn, we are also learning about organizing these events. So if there are any good feedback, please do share it to us. If there are anything which you want to improve, please do share it with us. We are on all ears. So Integrate, we are into the world of demand marketing. So we are a Martech organization, product organization. So our product qualifies leads for marketing campaigns run by major high-tech organizations in the world. Some of our major customers includes likes of Microsoft, Adobe, Dell, Salesforce, and soon SAP. So the workshop, I believe, is for close to 3.5 hours. So for 2 hours or so, you will be having an presentations and sessions, and the last 1 hour or so will be more of hands-on. So I'm sure a lot of you will be wondering, how do I be using the laptop? So there are rooms there. There's a cafeteria there, so you can use that to kind of do the hands-on there. There's a streaming which you see here will be present there. There are TVs all around. So do take pictures in the organization. Do share your thoughts or comments. Do tag us on LinkedIn. We would love to hear about that, your experience here. So with that, I give the mic back to Dinesh. So if you have any venue specific needs or any needs, please do reach. Okay. So thank you, Dinesh.
Once again, thanks Subhash for arranging this venue, a beautiful venue for this today. So so this is going to be the agenda for today, more or less. Like GenAI has been in the space for more around 2 years. It's almost going to be, and more than the hype, now we are able to see a lot of products have started to integrate AI into them, and predominantly most of them are RAG based, which we all pretty much know. So beyond the developers, every role in the organization, they have started to learn AI. And of course, you know the reason. If something AI related feature or a problem statement that has been better solved with AI means, then the QA person who is going to test the product need to know about this, how to test that AI related feature. If it is going to be chatbot, then how to test the guardrail. If it is going to be a vulnerable text, how to stop that, right? So like that, developers, product managers, QA, everybody need to learn that's the whole stuff. So that's why when I got to touch with Sri Jain, who is working in ThoughtWorks as data scientist, so he's already working in a couple of projects related to RAG, and he's solving it for different customers as well. So I thought, let us consolidate this as a workshop that includes both basics and also advanced concepts, and also real challenges which he faced in the production level, right? So that's where today. Of course, we'll be going from the basics, from the ABCs of RAG, and then some advanced concepts, and then real production challenges, how to overcome those challenges, right? So we'll be covering all these things as session, and workshop is going to be creating a RAG chatbot in your own machine. Okay, right. So that will be the day for the day, and with that, please welcome Sri Jain for the stage to present this session. Yeah, with a sound of applause, please.
Hello. First of all, thank you so much for spending your time and coming here. I hope I will make your time more valuable. Okay, I think you have all saw the title, everything like mastering production challenges in RAG. Like when we start this, right, it is none other than if we want to focus on the things what is going to happen today is like production type and the challenges faced in the RAG. Maybe we can take this as a overall agenda over here, and the three key points of the agenda would be like this. And if we move to the exact agenda is, maybe let's start from very scratch, very base, like let's start with the W questions like why RAG, why should we use RAG, what's in that happening in RAG, and when should we use RAG. Maybe I have included this contents like why should we use advanced RAG over here, what is the difference between the normal RAG and advanced RAG, what is advanced RAG over here, how we are evaluating the RAG system, and also we are going to see some prompting techniques, and maybe we'll continue with the hands-on part. Okay, let me start showing you with the demo, then see how the demo works. Okay, you could see a RAG chatbot application, a simple UI made out of Streamlit. I just want to show you how would be a RAG chatbot. The main thing is I have just taken a PDF of maybe I'm just trying to upload a 12th computer science book Python subject as a PDF over here to the RAG chatbot. Basically, to start processing the PDF, and once the process like involving like chunking, converting into embedding, storing that embeddings, we will see that everything in detail how that works. But if we ask a question over here, right? Maybe like what are operators? Maybe it start processing. If we ask a question, we have uploaded a PDF. The PDF has been processed, and using that processed PDF, ask a question, right? Then that question will be searched over the PDF, and it will be answered like a live agent over here. Maybe I'll just get the answers. I will just give. I think from the PDF, the question is passed through the PDF and got some results from the PDF, and that moves to a LLM where the answer is generated over here. We could see here. This answer is basically retrieved from the textbook what we have uploaded to the RAG chatbot now. We could see this in detail how this is going to work. Okay, let me start with where are we in this whole space. Actually, we all know what is. I mean, AI is a whole umbrella where it consists of machine learning, neural networks, deep learning. Now, new term has came inside that AI umbrella as generative AI. Previously, it was more familiarly known as NLP, natural language processing. Now, when it comes to Gen AI, now when it comes to Gen AI, it will be able to process the natural language processing. All the parts comes under generative AI. And once generative AI, inside that we have a large language models. Now we familiarly know with ChatGPT or Google Gemini, everything we chat that is interacting with a large language model. We will see in detail what is AI, what is generative AI, I mean what is LLM. Inside that LLM, now we have a new concept of RAG over here, where it utilizes the LLMs to give and LLMs and some other things to communicate with the users in a specific knowledge what the users wanted to give. Let us go inside. Okay, let's start with what is AI. AI or artificial intelligence is none other than like it is trying to simulate like human behavior and human intelligence. It is why we are creating AI is to like simulate humans, what humans do, right? We try to simulate that using a software. That software is known as AI over here. We have major two types of AI in here. One is narrow AI, other is generative AI. Before this November 2022, right? we all had a narrow AI concepts like normal machine learning and deep learning models, which are like a single task performer. Basically, if we give if we train a model, or if we give some samples and ask it to recognize something, it basically does a single task. Let me give some example. If we are training deep learning model, right? If we want to detect a laptop, then the purpose of the whole model is to only detect the model. Or if we want to detect a person, if we train a model like that, then its purpose is only to detect a person in the image what we pass. Or when it comes to machine learning models, like if we are trying to predict a sales prediction for the next year using the previous data as an input, or if we give the whole model scope will be like only predicting the sales of the company. That all model comes under the narrow AI. When it comes to generative AI, generative AI is like a multitask performer. Basically, like for real time example is, if we want to summarize text, if we pass on to a chat gpt or any llms and ask it to summarize the text, first of all it needs to go through all the lines and text and important keywords over there. It needs to understand the text, and then only it needs to summarize the whole text. It should not leave any important keywords over there. The summarization should be meaningful as the whole text we provided. So as now itself I describe, it is lots of processes happening inside this generative AI. So only it is known as the multitask performer. When it comes to multi-models, where LLM's upgraded version is a multi-model, where it can also understand images, understand text and images and simultaneously. So only I mentioned here it as a multitask performer. Basically, it is able to do multiple things at a time what a user needs. So only generative AI is so what to say, so a fuzzy word or a very boom. More people are getting attracted to generative AI due to this multitask performing capabilities. We move to the next. Okay, let me say what is LLM. LLM is none other than next word predictor. It is none other than a next word predictor. If we are giving an input, right, then it tries to understand that input and tries to predict the next word from that input. For an example over here, right, Bangalore is a city in. It is an input from the user side. Then it tries to predict the India is the next token. It just tries to predict. That's all happening inside the LLM. Basically, a large amount of internet scale data is given as an input for training data, so that it tries to understand the patterns between each and every word comes next in a sentence. So that only if we give a sentence, an incomplete sentence, it is able to complete the sentence more easily, because it has seen lots of trained data like this, like Bangalore is a city in India. Maybe still, if we need some visualization, right, we could see it over here. If we give an input like Bangalore is a city to an LLM, right, then it is not only India is the only word it is going to predict. It is going to predict lots of word over there, like world, Chennai, India, Karnataka, South India, everything maybe comes under its prediction. But it tries to give out the how much probability this word can occur. We can see here 40% is the highest probability having for the word India. We can see South India also 30% is over there. So it tries to give out the next token as the most highly probable word to show to the user. That's why, I mean, that's where LLM got hit. Basically, it tries to understand the user's input and tries to predict the correct next word. That's only happening in LLM side. Okay, right. You are what you eat. Basically, this is the first point where we start the RAG actually. You are what you eat means is nothing but whatever you give in a training data. Maybe the training data may be so huge, maybe like an internet scale data. Like ChatGPT 3.5 is trained over 15 trillion tokens. Tokens are nothing but like a word. We can consider it as a word. Maybe it is trained on 15 trillion words. So if we consider that it is a huge amount of data, still what is the failure point or not, what is missing out is a specific data or a data which is generated very recently from in the internet is missing out in that LLMs. That's only happening here. We have I think most of the people would have faced, if we ask some questions to any of the LLMs, right, it could say that sorry, I have trained only up to September 2023 or 2021 data. I have up to the data of 2021. After then, but people are needing to search the latest data which is available in the internet over the LLMs. So that points only we are trying to solve using the RAG. Okay, right? The basic example over here is, if you are asking a very latest query, like who won in the Google Technology Partner 2023, any local LLM which we are going to deploy in our production environment for any of our clients or any of people, or even internally if we are trying to use, right, it will be just saying like, I can't provide a real time information. My last update is from January 2022. This is what I am mentioning. So to solve this problem, not we could not solve all the problems over giving all the latest data available in the internet, but we could solve the use case what we are going through, like our own company data or our clients company data. We could able to give that as an input and make the LLM to answer the latest updated answers. I think now, as of now, we would have completed the question for why we need to use RAG. I think I could be able to say, I could justify that why we need RAG instead of using LLMs directly. Next, we could go with the question for what is RAG? What's happening in the RAG? Let me start with what is RAG question itself. If we are trying to ask what is your return policy in your company named XYZ, right? Maybe it could not answer by a normal LLM, because your own company has your own return policy, or our client's company have their own return policy. Maybe they could change it frequently, not even frequently. Maybe they could have changed 3 months ago or 6 months ago, but the LLM may not be trained. And the next problem is the LLM is mostly trained on the most common and most popular among sites. So it may not train on each and every data present in the internet for our newbie clients, or if we are starting a new company, then it could not able to be trained on that data. So we here comes the RAG. We can upload all the documents we have about our own company or our own clients. We make the LLMs to understand the latest data what is available, I mean, about our company, and make us answer to the user, so that the users feels like, okay, it is a chatbot which has all the latest information about the client side or the website they are visiting, or the chatbot where we are trying to deploy it. Okay. Okay. Why? Maybe here comes the next solid points for why we are using RAG. Basically, it is trying to improve the accuracy of an LLM. From the user point of view, it will be like a chatbot kind of thing, where the user will be posting a question and the user will be getting a question very within seconds. But it is not exactly trying to improve the accuracy of an LLM, because it needs some training data, training processes. But we are simulating like improving the accuracy of an LLM over here, providing the questions context to the LLM, so that it would be able to answer the questions more clearly or precisely. By using RAG, we could able to leverage the external knowledge sources. We have some personal documents, but the LLM could not have not seen that documents so far, right? So that documents and all, we could create a chatbot. We could ask some questions over there, and it could able to answer. Maybe this RAG or this whole application can be used in domain specific areas, like if we are focusing, our clients are like any pharma clients or infra clients, or any type of clients we are focusing on, so that we could boost the domain specific area also. This is much easier and much faster, and very fast go to market time will be very easy, I mean fast, when we compare to fine tuning a large language model actually. Then I have included a point like improves trust and transparency. Why I have included this point, right? Maybe most of the time we would have this much time we heard hear that LLMs are morely probabilistic and LLMs can generate false answers or LLMs can hallucinate. We have heard all those things, but when we are trying to use the RAG system, right? We somehow it would be answering from the data or the external data source what we have provided, so we could be easily able to track this answer is generated from which part of the document what we have provided. So if it says somewhat wrong answer also, we could easily able to track where is the this answer is generated from this part of the document what we have provided. So it is easily trackable. So we can, it is I felt like it is it improves trust and transparency over the client. Actually, this is the exact simple architecture of a rack system. If we want to build a rack system, not a production level, at least if we want to start with a rack system, we need to know about this architecture. Basically, this architecture we can divide it into two parts. First part is we have some documents or any web pages. Until that, to storing it into a vector database. This I consider it as a part, I mean part one. And the part two is something like user point of view. When a user asks some queries, it gets processed and it retrieves some text, and basically it is moved to a prompt template, and that is moved to a LLM. End of the day, LLM is going to answer the user. So this I consider as a part two. We can easily distinguish, and I will explain you both the parts. This comes under how to implement the RAG. Let me start with the part one of storing the data. As I mentioned, we have some documents, right? Basically, we have documents like anything like PDF or HTML documents, because sometimes we need to create a chatbot for our client to answer the queries which is already available in their websites. So on that time, we would be able to parse their whole website and convert it into we need to split it into chunks. That chunks will be embedded again, and we need to store it in a vector database. I know something chunks, a vector database. I will go through it in more clearly in next slides. But basically, we could be able to do this for images, Excel sheets, or any videos. Also, we can do this embedding process or storing it in vector database. Basically, your Google search uses this for past more than 5 to 6 years. To if we search a keyword, it retrieves the exact image what is expected, right? So that is all happening in this. But today we are going to see about only on text part, where we have PDF documents or any text files. We will try to store that and try to create a RAG system over that. Once our documents are ready, right, we need to split it into parts. We can't make a system or an application to digest the whole documents what we have. So we need to split it into parts. Then that parts will be converted into numerics like vectors, which is more easy for searchability. And this will be stored in the vector databases, where we will pass our query to vector databases so that it would be able to search the documents what we have provided into parts and retrieve that documents what we have uploaded. We will sure see in detail. I think as I already spoke detailedly about the loading part, where we have multiple data sources. Multiple data sources can be stored in vector databases itself. To store that documents, right, then we first of all need to chunk the document. Chunking means like if we have 5 paragraphs, right, we will be chunking each paragraph as chunk. For a normal example, we have a SQL database, we have each row, right? Like that, we will convert the whole PDF into small rows. Each small row is referred here as a chunk. A chunk will be stored in a row. How will that chunk be generated, right? If we are trying 1 million characters we have, right, we will be chunking each and every 1,000 character and splitting it as each and every chunk. That chunk will be converted into vectors. That vectors will be stored into vector database. If what happens if we don't chunk, right? If we don't chunk, then the whole PDF, if we the document which I uploaded now, right, that contained around 300 pages, around it has around 60,000 plus lines, I guess. That whole things will be converted into a vector. That vector will be stored in a single row. So whatever query you ask to this vector database, right, or a chatbot from a user point of view, the content which is retrieved from this vector database will be the whole booklet. We don't need a whole booklet. We need the topic. If we are, I uploaded a Python book, 12th Python book, then if we need about slicing, right, then we need the content only for slicing, not the whole 12th book itself. We don't need. So to get the only content related to slicing, then we need to split the textbooks into parts. Like the slicing may be a single row, then operators may be in another row, so that after converting it into numbers, right, it will be more easy for vector databases to pick up the exact exact context in the vector databases. So only chunking is needed. Without chunking, we cannot even build a RAG system, because it is pointless in building a RAG system without a chunking process. Because end of the day, we can't each and every time we can't put into an LLM a whole booklet. Even the LLMs cannot handle that much tokens at a time. So we need to split up into small parts and store it efficiently, so that when it comes to retrieval part, it will be more easier. Next comes the embedding. Embedding is none other than it is also a model. It is also now it is typically which comes under a branch of machine learning model. What is it is a single task performer. What is the task of this model, right? When the input of the model, it will be the chunks of the PDFs what we have uploaded, and it will convert into an embedding. This embeddings will be, right, each and every model based on its config, the embedding size will be different. Basic configurations will be like 512 embeddings. 512 embeddings is none other than that. If we have some floating points value, right, that will be a how much the context length. Maybe it is a single word or 1,000 words. Everything will be converted into a 512 embedding. Embedding is none other than a floating point which consists of vectors. The vector size will be like 512 vectors. 512 floating points will be there in the vectors. That is 512 embedding. Like that, for each and every model, it differs. OpenAI uses the embedding size of 1024, I guess. Like that, each and every model, how we train the model, right, it differs on that part. Once this will be acting as an index, uh, uh, acting as an index over the chunk what we have splitted, so that it will be easy for searching purpose. Why we are actually converting this text or the chunk we splitted into embeddings, right? It is none other than like we need to search the chunk, so that we are converting it as an embedding. How we are going to search and all, we will be seeing. But now what we need to understand is, we are getting the whole text document. We are going to split it into each and every chunk. That chunk will be converted into embeddings for storing purpose. That storing purpose comes under the vector databases, right? These vector databases are none other than like very specifically made for this storing the embeddings and the chunk purposes, so that it will be more efficient for searching in later on. Because if once a user asks some query, right, then that query will be also converted into an embedding, so that embedding will be try to search with other embeddings present in the vector database already over here, so it could able to retrieve the contents more effectively. I think as of now, we could, what I have explained, I have tried to put it in a visual representation. Let's think about that. First is, we have a large amount of data over here. Maybe I have given a small, a single paragraph. Maybe in our production use case, it will be like 500 pages, 1,000 pages. We have a large amount of pages over there. That each and every pages or each and every paragraph, we need to split it into chunks. Here we have around 3 points over there in this paragraph, so we are splitting that as an each and every point as a chunk. So once this chunk is ready, right, after this chunk is ready, we are just converting the same chunk into embeddings. the embeddings maybe it will be totally different from each and every embedding, and it would be more unique. But end of the day, each and every embedding will have the same size, which is made by the model as an output. As I mentioned, 512 as an embedding size, like that and all. So each and every chunk will be converted into an embeddings. That embeddings will be stored in the vector databases like this format. The embeddings will be like an index type, and the value will be the chunk what we have splitted. But because end of the day, if we our query is also converted into an embedding, it will be able to search in this list. And if we search also, what we are going to do with this embedding, we need this data, exact data, what is as a text, so that this text can be extracted and passed to an LLM. I think here comes the part two. Maybe like now, if we see this architecture diagram, right, we could get some more meaning. As of now, I have explained about the part one up to here. First of all, we have documents or any web pages. We are splitting into chunks. That chunks will be moved to an embedding model. That embedding model will be generating embeddings, and that embeddings and the chunks will be stored into vector database. As of now, part one of this is complete. RAG architecture is completed. Do you have any questions?
How many of you already implemented RAG? How does your table and images?
Sorry?
Your PDF has a lot of tables and
Yeah.
images. How does it?
Actually, if we are facing that tables or images in the PDFs, right, then to handle that itself, we need an advanced RAG architectures. It would be set in the RAG data pipeline itself, so that once the PDF is uploaded, text will be extracted separately. Images from that PDF will be separately extracted, and the tables will be represented in the different form. To make this LLM understand, here is a table, the table is in this format, that and all, we need to not manually, we need to write some script for that to handle that use cases. Currently, the RAG is automatically can be handleable with the text data, lots of text data also. When it comes to image or tables, we need to give more focus on that point also. I think any more questions or yes? India. Yes. Maybe first of all, I have. I have randomly gave that number, and I had some meanings also on that. Maybe South India was also a text over there, which is more preferable on that point. I think so. We have. It's a way long. Yes. Maybe India has the highest probability. Maybe I thought South India could be the second more probable thing. But this is a random number. But these numbers will be actually generated by LLM or embedding model, so that it will extract the exact text what is needed. But here I have for give a more understanding. I have just made a visual representation of the LLM. Mm-hmm. Sure. Based on the training data only, it tries to understand what are the text and what is the next word will be coming before the sequence of words. It is totally based on the training data, what it is trained. Let's start with the part two. Once we have stored all the necessary information and necessary data into a vector databases, right? Next comes the user part to interact. Basically, user will be asking a question. User will be asking a question to the chatbot what we have deployed. That question will be exactly passed to an embedding model. That embedding model gives an embedding vector over there. That vector will be searched in the vector databases. That happens in this retrieval part. Once it emits out some chunks which is related to the query, right? Then that query will be passed to the prompt template, with the question also will be passed to the prompt template. Both the prompt and the question of the user and the content which is related to the query, these three things will be passed to the LLMs, so that end of the day the LLMs can answer the questions, because the related answer of that questions is already given as a prompt input. So it would be able to easily answer the questions. So the user feels like the LLM itself directly interacting with him and answering real-time data. That happens in this. Maybe next will be like, okay, this is the next representation. Like this is if something a user asks some query, right? Then that query will be actually converted into embedding using the embedding model, what I have mentioned already. It is also a machine learning model, single task performer, as I already mentioned. Its only duty is to get text as an input, convert that text into a vector representation, a fixed vector representation. Okay, then that vector representation will be exactly searched in the vector databases and the vector database, and when the vector database will be giving out a most relevant embedding which matches to the query and gives out this value as a chunk. This chunk, maybe here I have represented one chunk over here. We can hyperparameter only, we can adjust it also, how many chunk it must able to give. Basically it tries to search all the nearable points in the vector databases. So it will give us a value as a chunk, and that chunk will be passed to a prompt template with the user query. The LLM will be able to answer more easily. That happens here. This much time I was explaining you vector databases. Basically, if we want to visualize the vector databases in a 3D form, right? This how it will be. Here, a wolf is a data point over here, a dog is a data point, a cat is a data point over here, banana and apple. We can see that here we could see that a wolf and dog, cat are in a separate side, and banana and apple are in the other side of the vector databases. Basically, what this embedding model does, right? This embedding models converts the text into embeddings which understand the meaning of the text, and then only exactly generates the vectors. If we try to plot that vector in a 3D space, right? So that only we could able to easily map the apple, banana, the fruits category into a single basket, and the animals like cat, dog, or wolf, or anything that comes under a large basket over here. So that only if we ask a query, right, that query will also be somewhere pointed near the other points. So it will try to find the distance between the 2 points from 2 points from the query and the solution chunk what we have stored. It retrieves the chunk which is more nearer to the query point. That only happens in the vector databases. This is a representation of vector databases. This is the most common three formulas which is used for calculating distance between the 2 points. This is the formula for calculating distance between point A and point B. That only happens in the vector databases totally. The point A will be the query embedding, what the user gives as an input as a query. That query will be converted into embedding. That from that embedding, it tries to find the nearest distance points which we have stored as chunks over there. So it will be able to retrieve all the chunk which is near the queries easily and give it as a chunk output to the LLMs, and we pass it with the prompt template. As of now, do you have any queries in the vector database part and calculating distance between the question and the chunk? Anyone have any questions, please? Yes. Yes. Correct. Exactly. Maybe it can also store metadata also, so that if that basically if starts storing the text part, metadata and anything can be stored in that vector database itself. So once the embedding matches, we can retrieve all the details related to that. Yes. Actual value. Meta may be like a JSON file where we have any values over there. Okay. Anybody have any other? Yes, yes, yes. Actually, it doesn't even know what is the word, what you are giving as an input, or what is stored as a word. It basically tries to understand both the vectors. So once the vectors generated by the misspelled words will be somewhat more nearer to the words which is already stored. So it tries to identify, matches the two vectors. So words is not involved in this picture of vector database and embeddings. Yes. Yes, there are lots of rules. There are advanced RAG technique for chunking also. Maybe we could see advanced techniques. What are the advanced techniques in later slides? We can have, yes, the vector database is always one. We can store lots of, n amount of data in the vector database as a chunk, so that it will be easy for querying purpose also. So once the query is asked, that will be moved to a vector database and the chunk will be retrieved from the vector databases. Yes, actually, that is a nice question. But the answer of that question itself is actually the use case what you are mentioning itself doesn't fit into RAG, because it is a structured data. Here we mostly handle the unstructured data like a large amount of text or large amount of images what we have. The structured data can be like easily be able to store in a SQL database. If you want to search, it could be able to do more efficiently than this. That use case doesn't fit over the RAG system. But this use case cannot be fitted into a SQL database. So we need to first of all identify, is our use case does really need a rack system. That is the first initial point of that. That is exactly true what you mentioned. There comes the advanced technique of RAG of chunking techniques. So if we are trying to chunk a leave policy or something like that, right? Then we will be chunking in the leave policy will be in a single chunk or a multiple chunk which is interlinked. So that if we ask about any leave policy matters, that chunk only will be containing the leave policy person A's number only. The chunk will not have a CEO's number. So the LLM can only answer from that phone number which is related to the leave policy. So we can handle in that manner. Yes. 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 First of all, I just need to correct a single bit. LLMs doesn't even have this or use this. Vector databases only use this. Most common people, most of the vector databases have this cosine distance. They have a particular option. If we want to change, we can change into Euclidean distance. But most of the people use this cosine distance as a normal matrix. Sorry, I'm very sorry, I couldn't get your questions. Maybe. Yes. Basically, when it comes to hello, when you try to ask a question directly to an LLM, for sure it is going to hallucinate or gives each and every time will be it would be giving a different answer. But when it comes to RAG system, right, this system mostly that query will be related to some particular chunks. The chunk what is retrieved may be shuffled. If we are trying to retrieve 5 chunks, right, that chunks may be shuffled, but the top 5 chunks will be more related to the questions. So the LLMs here, the role of the LLM over this RAG system, right? Its only duty is to answer the provided questions with the context of the questions what is provided by the user itself. I mean, or our system itself. So mostly it would not hallucinate in that point. So that only we are RAG became so popular in the enterprise space because it would not mostly hallucinate when it comes to RAG, because the data what is should be said will also be provided as a large chunk. What its duty is to understand the question and what is the exactly the user is expecting only it just needs to say. And also I have already mentioned we can also retrieve in which all parts of the PDF document or any text document is that exactly retrieved, that and all we can see. And we can also track what is the user's query, uh, what is the response it has given in the evaluation parts also. I think as of now, I think most of you are clear, right? The way it answer may change, but the exact answer, right? If we are asking about any exact questions, like what is the leave policy, within how many days should I return this product? If Amazon is making a chatbot, right, then I'm speaking in that manner. Within how many days we should return a product after we buy? That exactly is something like for example, if we take 14 days, that 14 days will be for sure consistent, because the 14 days is the data which is already retrieved from the vector databases. But the way it mentions, right, it is 14 days, or the sentence it forms for 14 days, right, that may differ, because that is depends upon the LLMs. Okay, right? I think now, as of now, I have tried to complete why part of why we need to use RAG, and how RAG, I mean, how and what is RAG exactly, how and works it also. Then we can see now when to use. Yes. Let me now say when to use RAG. I mean, this is also a very important part. Maybe I should have placed this before slides, before why or what, but I just wanted to give you what's exactly happening in RAG, so that it will be now more for you. It will be easily visualize or able to understand when to use the RAG. When it comes to this LLM space, right, there are 3 major techniques for making the LLM to understand our own data. One, the major technique is by giving the what all we expect a LLM to do, right? We can give that as a prompt itself, a exact prompt to what you should perform. What is your role? What do you need to do? What will be the user's input? What should be you respond to the user? That all we can set it in a prompt itself. Then we can ask a query; it will be able to perform on that manner. The second part comes the RAG system, what I have explained these much time. The third part is this is giving the LLM the data what we have in the more trainable format. Like we are going to train the model again by collecting all the data or having the data, what we have about our company or about what we need the LLMs to answer, right? The data we have, we change that format into LLM trainable format. Then we train the LLM or maybe fine tune the LLM. Maybe fine tuning itself a very large concept where there are lots of n number of techniques to fine tune from with very low configurations to fine tune the model with very high configurations or fully train the model we have. But the major thing here we understand here, right? First of all, prompt engineering is way more faster than the RAG system. If we are trying to implement a RAG system, right, we can just make a POC of using a prompt level itself. So we can, it is more easy, I mean, fast prototyping, easy to start. People may, we don't need any, I mean, any technical knowledge for implementing this. Just of all, we need to give a context in the prompt and ask. Okay, last we were discussing about prompt engineering is not a simple thing. It is also not a complicated thing. Basically, we need to have some common sense and the understanding of model. Basically, this prompt engineering is build how the model is trained. Like ChatGPT currently, or maybe like it could be able to understand whatever as an input we give, or whatever structure we give, it would be able to understand. But when we are moving to a production level RAGs application, and we don't want to use ChatGPT as an LLM, then when we are trying to use an open source LLM, right? Then maybe most of the company, I mean, each and every company has its own training prompts. So we need to identify that prompt over there. Maybe it is mostly available in internet itself. Like if we are using llama models, which is created by Meta company, we need to use open square brackets and mention sys sys as a system prompt what we need to give. And once your system fixed prompt completes, we need to give a square, open a square bracket, put a slash, then mention sys. These are all some prompting techniques over there. For each and every open source model, they have their own thing. Some people will be having different brackets. Some people will have different keywords for to mention this. We need to understand that part and do the prompting level. This next slide will give you some more clarity. One second. This slide will give you some more clarity when to use prompt engineering, when to use RAG, when to fine tune your own LLM. When it comes to content, the exact content optimization or the content what we need to I mean to the user, what should you give, right? That if it is a very more exact or a factual thing, moving to RAG part will be somewhat more helpful. If you really need your company's understanding or your client's company's understanding for the LLM from the scratch, I mean from the base level itself, even if sometimes if you wake up someone in sleep and also ask, means they must answer in a particular format or something, like for an example I'm saying, on that manner, whenever even the user asks a complicated query or any complication, it must answer more related to your company or your client point of view, right? Then we need to move like fine tuning part. But even though if you fine tune an LLM with the factual data, like he was asking like a leave policy, the leave policy may have their name, their phone number, the people may change also. But end of the day, still end of the day, we are going to train all the training data for the whole company's website or a whole company's data will be moved to made to a training data and fine tune an LLM, right? That may also hallucinate or give some false information. Maybe it could be able to generate the name correctly. It could have 10 digits as a phone number, but that phone number may be wrong. So that part comes the all the above. All the above, the other name of all the above here is RAFT technique. It is none other than RAFT is RAGs RA, Retrieval Augmented, and FT is fine tuning. We are going to build a RAG application over the fine tuned model. So it will be still more the company specific RAG application where we give it to our own company or use it for our own company or our clients. I think this would give you a great idea when to use RAG or when to use fine tuning or all the above. Basically, what is the exact difference between this fine tuning and RAG, right? The base LLM are going to be the same. If we are taking an open source LLM, for an example, Llama, or for an example, Pi 3 from Microsoft, the base LLM is going to be the same. If we are going to use the vector databases and embeddings and what I mentioned before, right, then it is going to become a basic RAG system what we are building. If we convert the same data what we have and then convert that data into a trainable format, each and every model has its own training formats also, as I mentioned for prompt engineering. Then if we prepare that custom data for our own data, our own use case, right, then we are ready to fine tune. Basically, the cost between both is, this is maybe a X, this is maybe a 10 to 50 or 100X for fine tuning. It is a more time consuming process. It is a more data oriented process. The quality of the data determines your LLM's performance. Maybe if, for an example, if your LLM was performing without fine tuning in 80% and your data is not that much good, it may perform a 60%. I'm saying that it is degrading. It is not meant that if you fine tune, the LLM will be performing the best. It's not like that. You need to understand what data we are making the LLM to learn. What is the use case? What is the purpose of the LLM to fine tune? Is this can be solved using RAG itself? Then why do we want to spend this much money and this much time over fine tuning the LLM? Right? So when this both gets together, right, a raft technique, this becomes still more beneficial for companies or the people who consume it. But how we do it is the more important thing. As I already mentioned, like if we consider this as an X amount spending, it will be like 10X or 50X or 100X. Because why I am saying this is, if we are taking this, if you are taking a base LLM, right, to fine tune, we should not use a quantized model. Basically, quantization means lowering the memory of, total size of the model. Maybe we could see that in later stage, what is quantization and all. But if you are taking a full base LLM, which is released by any companies like Microsoft or Meta or Mistral, any people, that will be around 40, 50 GB. I'm saying a 7 billion parameter model. We need to load that into a GPU. Then we need a GPU instance for that. We need to prepare a data set before that. Preparing data set involves multiple tasks, like you will be having a text data. How we are going to, basically the LLMs needed to fine tune means we need to make it into QA pairs. Then how are you going to prepare a QA? Then if you are preparing a QA also, it is not like that you can say, okay, let me, even if I now pass a document, a small paragraph to a ChatGPT and ask it to generate questions, it will be doing a best job. It's not like that. We need to, maybe if you are trying, if your company website or a client's website having lots of blog, right, maybe a same content somewhere related to another blog. It is not a single blog generating the questions for the single blog. It is not like that. We need to relate all the contents over there. So generating question itself a major task over here. We need to consider all these things and only start the fine tuning part. Once this is done, right, I think we have completed why, what, when of the RAG. I think RAG part will be somewhat clear in your mind, I guess.